Hello and welcome. We are your hosts Sandesh and Anshuman. In each episode, we will pick one seemingly boring security topic and talk about the good, the bad, and everything in between. So join us for some fun, some conversations, and some super hot takes about all things security in the boring AppSec podcast. Anshuman, welcome to the show. How have you been?
I'm good. It's been a couple of weeks since we've recorded, so it's good to be back. It's morning for me, so slightly weird to record a podcast episode in the morning, but all good here.
Yeah.
How are you?
I'm doing good, and for the first time, we're in close time zones, right? I'm kind of traveling across the US as well. This is the week before RSA, so I'm in the US, so it's kind of nice to be in the same time zone for a change. Okay, so it's been a few weeks since we recorded, right? And this episode I think is going to come out next week during RSA. I think what we wanted to talk today a lot is about incidents, right? And it's tricky to talk about incidents because it's one of those things where you can't really give up all the details, you can't really talk about everything you know about. But having said that, as an industry, we need to talk about this, right? And that's how we learn from each other and stuff like that. So I think here's what we should do today, okay? So let's talk about two incidents each, which we've been either involved with or heard a lot about. We don't have to go into the specific details of what company it was it a customer, was it a company you were a part of, etc., etc. So we don't have to go into that. So we'll try and keep it abstract. So some details will be missing, listeners. Please don't mind us. But the idea is to kind of give a sense of what incident management looks like in a security team, and kind of what lessons you learn from it and how things change, right? And in the end, we'll also talk about these these mega vulnerabilities that kind of come out every now and then, like the CVSS 9.5 type things. Kind of start with Heartbleed, I think, but we get these one every year or two every year these days. And then we'll talk a little bit about how we deal with those sort of like incidents as well, right? So that's kind of what we're going to talk about today. So we're going to do two incidents each, right? So Anshuman, you want to go first and talk about the first incident that you want to talk about?
Yeah, absolutely. So in one of my previous workplaces, again, without going into too much specifics about where, what, how, when, we basically used to sell these appliance products where our customers would install these appliances in their environments, and there were multiple versions of it. And I was on the security team of this company, and there was this Russian guy who would keep finding authorization flaws in our product. Like, just he was relentless, and he would just keep finding them one after the other. We would fix one instance, and then he would go and find the same kind of flaw in a different feature, like, so to speak, right? So reality was that we had some major design flaws that we weren't addressing, and we were just trying to fix instance by instance. You know how it is, right? When a bug bounty report comes in, you try to take a look at what that particular instance was, and you try to fix it, just because fixing the root cause or even analyzing the root cause will take days, if not weeks, and normally teams just don't have the bandwidth to do that sort of analysis and sort of address the root cause issue, right? So that was the situation where we had major design flaws, and this Russian guy, he was just too familiar with the product, and he I think also used our product for his client. Like, there was some context, there was some history behind it, predated before I joined, so I didn't have much context. But when I joined, I just kept seeing these reports one after the other. And then this guy, he created different pseudo handles, and we realized that like, no matter what we do, he's gonna find stuff, right? So, and then I vaguely remember that we stopped responding at some point to him because he was starting to threaten us, right, with the whole, if you don't fix this, if you don't respond, I'm gonna blog about it, this and that, right? So those kind of conversations started to happen, and it was really scary, right? And then what this guy did was he started to create different pseudo handles, and he started to write blogs about it, and those blogs were password protected, right? So he would be like, look, I have this blog, but it's not visible. I can give you the password, but only when you promise that you're gonna fix it. And then what he used to do was, we had this forum of sorts where our customers used to companies have forums where customers can be on the forum to discuss their problems if they have the same products and whatnot. So he started to post these blogs on these forums and the password as well. Our customers, somehow they got to know about all of these, you can call it as 0 days, just because he was finding them, we weren't fixing them, and it was in like an appliance product. So we couldn't just kind of do the update via a software update over the cloud or something like that, right? Like, customers had to make some changes in their appliance, so to speak. So that was really the situation. And I think I remember there was one day where we just started seeing a bunch of customers reaching out to us and asking questions about, okay, what happened here, and we thought we were hacked big time. right? Just because we just didn't know what happened and what information the customers were asking us and where were they receiving all of this. And then, we figured that it was a Russian guy. He was trying to create this sort of attention, so to speak, so that we would focus back on him. Because at some point during this I think whatever I'm kind of explaining happened over the course of 2 years or so, right? So it started off, the relationship with the hacker started off really well, right? Like, he used to send us reports, we used to fix it. This kept going on for a few weeks, and then gradually, it became so bad that we were just scared to release any product, because we knew the guy would find it and he would post it on the forum, things of that sort. So yeah, I don't know. It's a very weird incident, so to speak, just because as a security engineer, you don't deal with such hackers, right? Like, most of the cases I know, we deal with white hat hackers, researchers who participate in programs, and they report issues responsibly, right? And they don't generally disclose if we have a clause in a program and whatnot. So yeah, this was a very weird experience, and the reports were also so detailed. Oh my god, like, I used to spend hours on each report trying to understand, trying to reproduce, trying to figure out what exactly is going on. Like, he understood the product much better than I did, or than our engineers did, the engineers who wrote the product did. That's how hackers are, right? They just have that curious mindset, and they just know how to break stuff. So yeah, man, like, my job wasn't to just kind of deal with it, but at some point it did become that. I was just kind of dealing with this hacker sending us reports and whatnot. I think we even tried to connect with him. We even tried to hire this guy at some point, and then, as far as I remember, this is like a few years ago, and everything just stopped. He just vanished. He just disappeared somewhere. I don't know what happened. I still don't know if he's still there. But that was really, kind of the summary. I know I sort of, so that was it. I think I just want to cover the lessons that I sort of learned. So I think, first is obviously addressing the root cause, right? If you find multiple instances of something, there has to be a bigger picture, there has to be a bigger design flaw, and if you don't address the root cause, you're gonna keep getting at it, right? So that's one thing. The other thing I have in my notes is, the risk mitigation doesn't always work when you have someone dedicated to find bugs and knows the ins and outs, right? So in other words, the hacker knew the product much better than we did or our engineering team did, so we can't really expect our team or us to mitigate the risk, because the hacker knows how to get around this product, right? So no matter what we do to mitigate the risk by not addressing the root cause, he's going to find the loopholes again and again. So that was one thing. The other thing is, Russian people are crazy smart. I have this in my notes, and I have heard so much about Russian hackers and these crazy, I don't know, like fiction stories and whatnot, but this guy was just brilliant, man. This was my first experience of dealing with a Russian hacker in real world. It was crazy.
That's a really interesting story, right? So a few things pop out to me when you talk about this, right? So one is that, incident management is a little different from building security, simply because one, there's this weird timeline pressure that you have, which needs you to kind of respond quickly as opposed to fix stuff, right? So what you said about, hey, mitigations don't work, you have to go fix the root cause. That is true, but the root cause fixing may take 2 weeks and you can't sit around and do nothing in the meantime, right? So I think it kind of needs a different kind of thinking, right? And I kind of feel like, application security engineers are usually not very well suited for this, right? But when I talk to like actual security operations folks, they have a very good sense of, what are the knobs they can turn to kind of reduce this attack, right? Like, can you geo-block IP addresses? You will do that, and then they'll find another bot, and then you do something else, and then they'll find something else, right? So I think it's a kind of a game of cat and mouse anyway. So I think, to summarize what you said, until you're able to fix the root cause, you've got to try all these mitigations. But the problem happens when, the powers to be assume that the mitigation is the fix, right? And that is absolutely not. I mean, the compensatory controls are compensatory controls, right? You've got to kind of fix the root cause in the end. And the second lesson for me is that, there's time heals all, right? Even hackers get bored and they kind of stop doing it. In one of the incidents that I was involved with, I wasn't planning on talking about that today, but what we kind of learned when we kind of try to learn about how the hacking ecosystem works is that usually the person kind of who's initiating the hack is not necessarily the one who's carrying it out. So someone actually, this is a very sophisticated system, right? So in many cases, sometimes it's not sophisticated, but sometimes it is. And when it is, essentially what happens is that there's a person who wants to hack a particular target, and they kind of outsource the work to somebody else. So when they outsource the work to somebody else, there's a budget, like whatever, $100,000 worth of hacking, right? Is what they buy. They buy it like they buy, credits, right? So when they do that, so they're essentially going to do it until until they run out of the money, right? Because hacking is also quite expensive, right? Maybe not all kinds of hacking is expensive, but it requires, like you said, it requires talent. You need to be a smart person, and if it's an individual doing it, maybe they'll get bored and move on to something else. But if it's a nation state, or if it's a financial actor, they'll try their best until some point, and then they're going to stop, right? So it's weird. I don't know what the key lesson here is, but understanding how a hacker thinks and how an adversary thinks is kind of actually useful as well during managing incidents, right? So that's kind of the second thing I want to say. The last thing I'll say, and I think this is what is really weird about security incidents, is that most companies, even if they're small, have some kind of an incident management setup, right? When your application goes down, your DB stopped working, or or there's some issue with your infrastructure, and so on and so forth. So they're very used to working on that. And what happens in those scenarios is that there's a bit of an all hands on deck approach, where you kind of try to break down levels of communication, make it very easy for everyone to know exactly what's going on, and therefore you're able to solve the problem, right? And this kind of screws up when it's a security incident, right? So in the company you mentioned, I'm pretty sure it wasn't like you folks were broadcasting to the entire dev org saying, hey, we have this hacker who's trying to screw us over, can you please help us out? Right? Like, that's not something you can do, right? But on the other hand, if your DB is down, because of a messed up query, then everybody knows about it. It's easy to kind of join forces, right? So that I think is the other issue with security incidents that you have to think through on what kind of the workflow is. And I'm not a big fan of like security drills and stuff, but in this particular scenario, I think it works, right? I mean, it's useful to say, hey, here are the 7 kinds of incidents you can have, and for each kind of incident, here's how we are going to respond if it happens. And then you never end up following exactly what is in your runbook, but at least it tells you like 60-70% of the way, and at the end of every incident, you're able to kind of like update the runbook and make it better, right? But that's kind of my takeaway from that. And also the other thing we can talk about it is that, whether you're an appliance company or an internet first company, depending on what kind of company you are, your incident response also has to change. So if you're an appliance company who are deployed in 1,000 different locations, pushing an update is not straightforward. But I think you have a lot more compensatory controls there, because you can think about customers whose appliance is on the internet versus which is on the intranet, and you can kind of like prioritize there. But knowledge about how your company works, I guess, is really important.
Just one more thing to add to that. Just as you were speaking, it came to my mind was, I think it's also really important. So I think we might have spoken about this in one of our previous episodes, but the difference between a product security response, kind of a team, versus just kind of a general incident response, right? So most companies that we know of will have like a good incident management policy, teams that just kind of do incidents all day, every day. But then there's also a difference. It's like one layer deep when you think about how product security teams manage incidents in their products. It could be considered the same sort of an incident, but it's not really. Like, there's some nuances to it. There's some technical details to how a product security incident should be handled, and I think it's really important to sort of know the difference and know which hat to put on, right? Like, are you being a product security engineer? Are you just being a security engineer? Because I think that makes a huge difference on how you handle incidents.
That's a really good point, and that's a good segue to kind of the incident that I wanted to talk about, right? So this was many years ago. I don't want to kind of state exactly how I was associated with this, but I'll tell you the incident thing, right? So the idea was, this was a place where you were able to kind of they had like some kind of a mobile app, and this was many years ago, right? So the technology was not as good as it's in the last few years. Many years ago, they had a mobile app, and people were able to kind of, quote unquote, steal money from the wallets. Not real money, but they were able to kind of add points to your wallets, and the points are worth money, and so on and so forth, right? Very typical kind of your, kind of like a fintech thing where you have wallets which have coins which are equal to cash, and therefore if you can steal the coins, you can essentially steal cash, kind of a thing. So in that kind of a scenario, so that happened, and people and the company who owns it kind of realized that they're definitely losing money in one way or the other. And I think the response to it was interesting, because this was a pretty large organization, and they kind of knew exactly how to respond to incidents. So they got an incident management team. The idea was to go look at logs. They were looking at traffic. They were getting like database dumps. They were doing forensics, and nothing looked different, right? Because the reality was this was actually like a business logic flaw in their workflow. This did not need you to go do forensics. You just needed to go understand how the software was written, right? And that is not something a forensic audit team or a security operations team is good at. So to your point, what essentially helped is that we had like application security pen testers take a look at it, and then essentially they were thinking about it from how a developer does. And again, this is like a large company, so the developer and the security team are not even in the same building or in the same company, right? It's all outsourced and stuff like that. So it's like a weird setup, but nobody nobody really understood the code end to end. Essentially, the job of the application security team became to reverse engineer and understand the code and then figure out what the business logic flaw was. And they didn't need to do much forensics for this. They just need a dev environment where they could play around and do some QA stuff and then figure out saying, oh, this is the business logic flaw here, right? And then they kind of realized that this requires almost like a rewrite of the entire application. So, they couldn't really fix it. So they found a way to mitigate it, which I'll not talk about, but they did find a way to mitigate it, right? Which is not, and the simplest mitigation in general, by the way, is to bring this stuff down, at least until you can fix it, right? Like that's mitigation 101, right? So they were able to do some of those things and solve the problem and stop the bleeding, so to say. But the point I want to make here, to your point, right, is that there is like an incident playbook, which is kind of like from 10-15 years ago, when most incidents were at the network layer or at some kind of infra stuff, right? You kind of find a way to, you find keys to the database and you steal everything and stuff like that. With AppSec, it's a little different because the personas who can help you figure out what exactly happened are not the people who you typically associate with incident response. And the second thing is, if your software is not well written, which means that you don't have good logs. And if you don't have good logs, you can stare at your Splunk instance for days, you'll find nothing because nothing is properly logged, right? So, the quality of software development becomes important as well. This is my way of saying that if you want to have good incident management, you have to have good planning. You have to have good software development, and only then it really helps being an incident manager, right? Otherwise, your incident response is going to be flying blind, depending on humans' ability who know tribal knowledge in the company and stuff like that. But this was a really interesting incident. It went on for days. I kind of remember spending nights kind of looking at it for a while. It was a great learning experience for me, and we learned a lot about incidents for sure.
And I think I sense a common theme between both the incidents that we just discussed was like addressing the root cause is what it really boils down to, right? And if you don't do that, if you just kind of keep focusing on compensating controls and whatnot, the whole incident management is going to be a pain, right? So I think that this is just like a common theme I observed over the years of my working, right? And having seen or having been a part of multiple incidents is, there's a thing called postmortem, right? Which I'm sure you're familiar with, which most companies do, right? After an incident is they kind of ask themselves questions of why. Like, I think this was something I really appreciated when I was with Atlassian, and I think it's okay to name Atlassian here is because they just had a very incredible incident management plan where, after every incident we would do a postmortem and we would keep asking 5 why questions, right? Like, why did this happen? Okay, this happened, but why is this in the first place, right? And it basically allowed us to sort of do a root cause analysis, but not really from a technical standpoint, but just kind of asking questions and having those conversations in the first place. Very difficult conversations to have. We had a very blameless culture, so it wasn't like I was trying to blame a different team, and so that just wasn't there. And the whole culture about incidents in Atlassian, I have to say I was really impressed. I really learned how to think about incidents when I was with Atlassian. So man, I think it's important to have a good incident management team, a run book, a policy, just kind of teams knowing what they do.
No, I'm with you, right? I mean, I'm just going to link a blog in the show notes. This is nothing with security, but on the 5i RCA format, right? So, this is something that, the folks at Razorpay also implemented. And I think this blog kind of talks about how they do incident management at Razorpay. Again, this is not specific to security research incident management, but this brings back to a point we spoke about many episodes ago. Security is not special in some ways, always, right? Obviously, security incident management has some nuances, which is not the same as other incident management, but a lot of the lessons can be learned from there, right? And I think the RCA is just a phenomenal thing, right? I mean, if you are a company which takes RCA seriously and you actually learn lessons from it, you will actually see your incidents go down, and more importantly, the stress levels go down. If you're always relying on that one superstar security engineer to bail you out in every incident, man, that superstar engineer is going to quit, right? So you better kind of find a way to kind of make sure that you have a larger team and etc. etc. And I really like the 5 Eyes format. I think it's a great way to get into it. But it's one of those things where once the incident is over, people stop worrying about it. It's amazing how it takes no more than a few hours after the incident is done that people just go back to as if it never happened, right? It's kind of like after COVID, right? I mean, we suddenly forgot everything, right? All the lessons we learned, right? I mean, it's just human nature, right? But I think that's kind of where a thing like an RCA is really important because it's like a process step which has to happen. And my recommendation is that if you're kind of building a security incident management team, that make sure your top leadership is involved in the RCA process. Like this is the thing they have to be on, right? Otherwise, it's very easy to write a banal, pointless RCA, which basically says, hey, the incident happened because of ABC. Nobody really knows why ABC happened. You don't take it seriously. It looks like a nice report, but it actually isn't a nice report, right? So I think, the incident, the RCA itself I would say is actually as important as managing the incident, because the managing the incident is all hands on deck, do whatever it takes to get things done right, but that's not scalable. What's scalable is that you will really, really learn lessons from it. You spend a lot of time figuring out what the hell happened and then take appropriate action, right? So yeah, I'm with you that the RCA and the 5 Whys thing is very good. We'll link a blog from the Laser engineering team on kind of how they improve the RCA format. I think that's a very good place to start.
Yep, absolutely, man. All right, so I think let's move on to the other incident. So I think the one that I covered before was like an external incident, right, where something happened to us, right, like by an external actor, so to speak. The next incident that I'm about to describe is more of an internal incident, right? So again, in one of my previous workplaces, our security team, we built a bunch of internal tooling, right? And the one thing that we built was like a complete end-to-end vulnerability automation, like sort of a platform slash system where if we would find a vulnerability in an application or like an endpoint, we created a Jira ticket for that issue. We attributed the Jira ticket to a particular owner, whoever was on call. We would assign a SLA to it, and then as the ticket reaches its SLA date, right, we would follow up if the ticket hasn't been actioned upon. So the complete process was automated end to end, where there was no involvement of any humans, right? Like a ticket would open up, somebody would try to take a look at it and try to fix it. It would rescan, right? Like once the issue was open in the engineering backlog, somebody would try to fix the issue and they could close the issue by themselves, right, if they believe that something was fixed, and then that would re-trigger a rescan of that issue, right? And this was all completely automated, and if the rescan found that the issue was fixed, we would automatically close the ticket ourselves, right? So it worked like a well-oiled machine, right? It would just work fine. We had metrics, we had everything that we really needed, right? But I think one day what happened was there were some inconsistencies, there were some edge cases with the scanner that we built that we didn't really address. And because of that, I think with one particular application, the scanner just kind of faltered or failed, or I don't know what the right word for it is, but we saw a bunch of tickets getting closed automatically. I don't remember the exact reason why. I think it was because the way applications worked kind of changed, and I think there was a PR for our scanner that kind of introduced another logic in the scanner itself that wouldn't consider all the edge cases, something along those lines, right? All the tickets would automatically start closing, and there were conversations or Slack messages that automatically started getting sent to our engineering teams, and we started freaking out, obviously, right? Because this is not the experience. This is the last thing any security team would want if they build like a fully functional vulnerability management platform, right, where things are just not working. And I'm just not talking about issues itself, just the process. The process failed, and this was like an incident of a process failure. This was an incident for our internal security team where we built something where, again, if you think about it, not really software engineers, we are security engineers trying to build something. So I think this was one of the lessons we learned was, if a security team is building an internal product or tool for the company, even if it is not production grade, but still it is something that is being used, and you start small and then slowly people start using this thing, and then suddenly it becomes this huge thing. And if you don't focus on the observability, if you don't focus on the things that really makes sure that it is robust, it is you have the logs, you have everything, right? You have to work with like an SRE team or like a software engineering team to know exactly what needs to happen there. So I think this was a big lesson that we learned, was we relied too much on what we built and we didn't pay attention to the observability aspects of it, and this was a big failure, right? So so that was one thing that we learned. The other thing was there has to be a human in the loop, right? Like we talk about humans in the loop in like AI world, right? But I think even when it comes to vulnerability management, and I think we have spoken about this in the past, is you can't really automate vulnerability triaging, right? You can, but there are going to be edge cases, there are going to be certain aspects to it that you most certainly will miss, right? So I think that is the other thing we learned, was in this sort of a system where you're completely automating end-to-end vulnerability management, you have to think about multiple edge cases. You have to introduce the like some human somewhere to make sure that the process is not failing the way they did for us. And then the third lesson for me was customer impact takes a precedence over everything else, right? If you're building something to serve customers, and if the customers are impacted, you have to drop everything and you have to address it, right? And it was a big thing for us as a security team, because that's not what we do on a daily basis, right? Like our customers are internal engineering teams, and it's not like we have SLAs, we do security reviews and whatnot. So, but this was something really important.
Yeah, no, I think the customer part is really important, right? I think this. I mean, I think it's a bit of a theme on the show that you gotta have empathy to all the stakeholders and all that. We probably sound like therapists, like bad therapists, right now, right? But I think point on customer impact and kind of having empathy for that is actually really really important in the sense that it's. I mean, maybe in one way you can say it's not your job to do that. There's probably somebody else on the team who's kind of worrying about that. But obviously, there's a difference between an incident which a customer knows about and a customer is panicking versus an incident where only you know about it and the customer doesn't, right? So this is kind of why like a DDoS attack or a data breach, usually a public data breach, has a lot more urgency to it than, let's say, something where only the security team knows that something's gone wrong, right? And I think, again, preparation is everything. You'll really, when the first time it happens, it's okay to panic. But on your 7th incident in 9 months, if you're panicking and reacting instead of responding, then you kind of, you're not doing your job before and after the incident, right? There's a reason it's called incident response and not incident reaction, right? Because you're not supposed to just go with your gut, right? You're supposed to have a process. You're supposed to think this through and so on and so forth. So a lot of incident management is really about what happens before and after the incident, and only that training kind of helps you deal with what's happening during the incident. So I agree with you completely on kind of figuring out not all incidents are the same. Like you said, internal when it's an internal actor, you probably have to respond very differently from say it's an external actor. When a customer knows about an incident versus a regulator knows about an incident versus nobody knows about an incident, how do you react are different things. And I'm not saying one is more important than the other. It's just that you have to think through these things before the incident happens, right? And I think that's kind of what's important. Okay, so the last one I kind of want to talk about today is on this trend which probably started, I don't know, in 2012, I guess, on with Heartbleed, which is of these mega critical vulnerabilities in mostly open source software, but sometimes also in commercial software, where essentially you find this really, really high risk vulnerability in libraries which like every company in the world uses. And then the owners or the maintainers of the library essentially thoughtfully come up with solutions and basically publish it in a time where basically good engineering teams have enough of an opportunity to fix it even before the hackers get to it. So Heartbleed is a great example for it. Log4j is a really good example for it. Recently the XZ app is a good the compression library is a good example for it, right? So all these are really good examples, right? So the one I wanted to kind of talk about is Log4j because I think everybody who's been in security for more than 3 years probably went through this, right? Because of how ubiquitous Log4j was. And to be honest, I think we've kind of spoken about this in other forums as well, is that kind of the whole Log4j weekend, it came out. So TLDR on what Log4j is. Log4j is like a logging library in Java, a very, very popular logging library. Essentially gives you like a bunch of functions to make it easy to log warnings, log error messages, and so on and so forth. But there was basically a vulnerability which could lead to an RCE of some kind, right? I'm blanking out on the exact details of what happens in Log4j. But the idea was that you had to find every instance of Log4j being used and then update it to the latest library, unless you were using a really, really old version, in which case you didn't have to worry about it because the vulnerability was introduced in somewhere in the middle, right? Now, the problem with this is that this is kind of like the application security masterclass. Because step one, you need an inventory. You need to know where you're using Log4j, right? Step two, you need to kind of figure out, if you need to have like good test cases, because if you fix it and then the fix actually breaks something else, then you don't know what to do, right? And there's a possibility that you have to update like hundreds of services, dozens of applications for it to work. And then three, you may have third-party applications which you're using who may not be updating it because they're a small company and it's like a one-person company and that one person's on vacation type thing, right? So it could be, so this was kind of a really, really good example of an incident with no impact, right? So there was no one really hacked us per se, but we knew for a fact that if we don't treat this like an incident, then we're gonna kind of it's gonna become an incident then. So I think the real kind of lesson here, and I'll link we'll link a talk on Log4j itself to if anyone's interested in knowing exactly what happened there. I think the lesson for me here is that one, if you're building a security incident response team, this is a category of incident that you have to prepare for now. It's gonna become more and more common. There's almost an industry standard now on how to report these things. It usually comes up on a Friday night Eastern time because that gives time over the weekend for security engineers to come and fix it before Monday morning. Counterintuitive, it messes with our weekends, but it's better than it happening during a release on Monday afternoon, right? So that's I think there's a consensus that this should break on Friday evenings. And the second thing is that you usually know the solution to the problem in the sense there is an update available. It's well documented. There's already probably some literature on how to do the updates, etc. already available. So those things are already taken care for you. So that's great. But the real issue is that you have to understand your environment really, really well in order to kind of be able to pull this off. And second, you have to have protocols in place to say, hey, this is happening on a Friday night, so you got to pull in the right people on Saturday or Sunday and figure it out. In some cases, it may be the case that you can do something on your WAF, you can do something on your endpoint in your endpoint protection, kind of make sure that you can push the remediation to Monday. But that's an analysis you have to do, right? Can I mitigate this for the weekend and pick this up on the week on next week? Cannot. How do I get in the necessary people over the weekend? And third, how do we know where we're using it, what needs to be updated, how does the inventory work, and so on and so forth, right? And I think this is something that teams will have to start building, right, as a part of their incident management process or as a subset of their incident management process, right? And again, like I said, there was a lot of lessons for us. Our whole the left cartography thing that that you and I spoke about a long time ago, I think came out of this, essentially saying, hey, if you're going to do this, then we got to do this right. Usage of S bombs and stuff became a lot more prominent after Log4j for many companies, purely because of the fact that hundreds and hundreds of companies were trying to scramble and figure out where the hell we use Log4j, and the answer usually was everywhere, right? And that's not helpful. So you'll have to kind of figure out exactly where and things like that. So that was kind of the fourth and the last incident I want to talk about.
Yeah, and just to add to that, I think you were breaking up, so I'm not sure if you quite covered what I'm about to say. If you did, just feel free to pause me. But I think so. There was a term that we came up with, like in one of my previous workplaces. I think we used to call these vulnerabilities as high profile vulnerabilities, and we had like a separate incident management or like a vulnerability management process of high profile issues, just because they were high profile, and we knew that we would start getting inquiries from customers and whatnot. And I think I also remember, not necessarily with Log4j but with Heartbleed, I think I was with EMC at that time, and with EMC I was in the product security response center. So my job was to actually respond to security incidents and vulnerabilities reported on EMC products, right? So I was on that team when Heartbleed dropped, and oh my god, man, I have like horror stories from that time where like when Heartbleed came out, it was panic more than like just kind of like people just didn't know what was happening, just because there were different variations, right? Like there were different SSL versions that were affected, and there was like some versions weren't, some versions were. And generally when you work in a product company like EMC, right, like you have products that use different SSL versions across different products. So it's not like you just use one version and if you know that you're not vulnerable, you're good. That wasn't the case. And I think even for each different variation, there was like there were different POCs and whatnot. So the whole thing was just kind of, and I think Heartbleed was probably the first major high profile issue which became a big thing. And then I think after that we've had a bunch of other things, right? But Heartbleed was when our industry just got dropped this thing where there was a website, there was a logo, and again, like these are some things that these issues have started to have more, right? Like there has to be a logo, there has to be a website, the name has to be cool enough, there has to be a POC, right, which somebody has built. So there has to be all of these things that go with these high profile issues. And I think over the years companies have gotten much better in in addressing and knowing, or at least finding the signal when something like this drops. But when Heartbleed came, oh my god, it was chaos. I still remember those days. I don't want to go back to them. Yeah, man. Good experiences and so much to learn.
I mean, I'm kind of in two minds about this whole giving a logo with a bleeding heart and all that. I mean, it was I mean, I'm not blaming the Heartbleed, the folks who did that. It was actually, I think, from the researchers at Black Duck during like a Google hackathon or something when they found it. And I kind of worked with the Black Duck team a little bit in my days in Synopsys. I think that's fair. My sense is they were trying to kind of replicate what the hurricane systems have in happen around the world, right? You give hurricane a name like Hurricane Sandy or whatever, and then it kind of makes it more real and it's easy to kind of identify and stuff. I kind of hope we don't do the whole logo thing again. It kind of reeks of marketing. Again, nothing against the people who did Heartbleed. I think that was the first time that we were doing it, so nobody knew how to do that. But now I hope, I'm like websites for it, and like you really had the time to come up with the logo when you were doing this. That's weird, right? Nothing wrong with it, but the optics seem off. I kind of liked what happened with Log4j. I think it was kind of well done. Even with XZ, I think it was kind of a like a good way of doing that. And this is going to be a reality for if you're a security incident management team, and it's best to get ready for it.
Just to add like one more quick thing to this. So there's also this concept of embargo, right? I'm sure you've heard of it, right? And especially if you, again, like when I was with EMC, right, like we would have these sort of email email distribution list where, if things were found in, let's say, OpenSSH, whatever, right, like different versions of some common libraries that are used basically in the entire world, we would get to know about these issues much before the actual website was out with the logo and all of that stuff, right? So this whole concept of embargo, where you essentially form some kind of an agreement with the reporter and the company who's supposed to fix it, and then there's some secret channels, not secret but more so closed channels, because everybody wants to be responsible in addressing these high profile issues, right? So I think there's also like a good, like some good in this, where folks who do find these high profile issues, because I think Heartbeat was found by Google engineer, right? I think Neil Mehta or something, I don't remember his name, but I think it was just a very simple issue, right? And if somebody like that person finds something like Heartbeat, yes, I think the intention is to be responsible. The intention is to make sure that we know SSL is used pretty much everywhere, right? So this particular issue, whatever we find, is going to affect pretty much everything in this world. If you think about it, it is crazy, right? So how do you even begin to explain this to the world, right? Like just imagine finding something like Heartbeat yourself and just not knowing what to do. Scary, crazy, right? But yeah, that is essentially what happened with it.
No, I'm with you, right? I mean, I never actually thought about it this way, right? I mean, but yeah, it must be like a nerve-wracking few days, weeks, months. I mean, I've dealt with like very, very smaller version of that. When we found a bug in our company, and we were like, okay, what's the root cause? And we kind of went going deep into it. We figured out it's like a third-party system, right? And the point is that we were excited about it. We were like, hey, this is pretty cool. But we kept reaching out to the third party, and they never got back to us. And we were like, okay, what the hell do we do now, right? Because we know there are other companies who are kind of using the same library and have the same issue, right? Eventually, we worked with them. We got the CVE out and everything. But in general, I think you're right. I mean, there's certain cultural things about being in security which is so weird that nothing prepares you for it. Thank God we have a community which kind of helps you deal with these situations. But I can imagine being in the head of the team which discovered Heartbleed and had to keep it down until they found a logo and the time to release it. That must have not been easy. All right, excellent. Hey, so I mean, look, the one last point I want to kind of make here is that when we talk about security incident management, we are kind of talking about relatively smaller teams, and we haven't really spoken about the hacker mindset that much here. Depending on who the hacker is, like is he someone, he or she, are they someone who are trying to kind of steal money? Are they doing it for fun? Are they nation state? Your incident response trends is there too. So the one kind of parting point I want to make is a lot of this is very, very biased opinion based on our experience. We are in the world's largest bank. If you're in like Bank of America or Citibank or JP Morgan, your incident response does not look like what we said. I can guarantee you that, right? It looks very, very different, right? And if you're a tiny company with no security team, then your incident management looks very different, right? And depending on what your company is and what it does, a lot of it can be different. But a few principles kind of remain the same. RCAs are really important. What happens before and after incident. Preparing for the incident is really important, and kind of during the incident, clear communication and having people on the same page is really important too. So with that, I think that's all I had for today. Anything you wanted to add, Anshuman, before we wrap up?
No, I think we're good. Let's keep it short.
Okay. All right. Well, thanks everyone for joining, and we'll see you next time. Thank you. Thank you for joining us. If you like the show, please share this with your friends and colleagues. If you have any questions or comments, you can reach Anshuman on Twitter at Anshuman_BH. That's ANSHUMAN_BH. And me, Sandesh, at Jubba on Jeans. That's JUBBAONJEANS. See you next time.